the previous class we have done the basic concept of a matrix, and then we have completed a square matrix, symmetric matrix, skew symmetric matrix, orthogonal matrix, unitary matrix, Hermitian matrix, and a skew Hermitian matrix. Now today we shall do some more basic concept, that how to find out a determinant. So determinant, you know that we have to write down the matrix as a modulus form. In this case, suppose we have a matrix 2 minus 1 2 4 0 9 and minus 7 3 minus 1. Now you have to write down the matrix and in the modulus form, and you have to expand it and find out the determinant. The determinant is generally denoted by capital delta, and we shall expand it by first row. And suppose we expand it with 2 minus 1 2, then you will have like this. That will be minus of minus 1 4 9 minus 7 minus 1 plus 2 4 0 minus 7 and 3. This you have already done in 10 plus 2 class. This is 0 minus 27, and this is plus 1 minus 4 plus 63, and this is plus 2 12 minus 0. So
सर माइनस आएगा, -63.
this is minus sign already. Minus sign
-63.
is already there. So that is why they come out to be plus. Minus 54 is there. Minus 54 is there. And this is 64 minus 3 is 59. And that is 12 2s are 24. Ultimately, we shall have 29. This is the value of the determinant. So by this way, you can find out the determinant. जब हम लोग डिटर्मिनेंट फाइंड करते हैं तो एक टर्म आता है कोफैक्टर्स. कोफैक्टर्स भी हम लोग फाइंड कर सकते हैं. और इसमें इफ वी वांट टू फाइंड आउट द कोफैक्टर ऑफ 2, so cofactor of 2 is this. This is your determinant. तो cofactor of 2 अगर आपने ऐसे लिखना हो कि हमने सेपरेट सिर्फ कोफैक्टर ही फाइंड करने हैं, तो कोफैक्टर ऑफ फर्स्ट एलिमेंट 2 is equal to -27. द वैल्यू ऑफ दिस डिटर्मिनेंट, जो इस डिटर्मिनेंट का वैल्यू होएगा वही कोफैक्टर होएगा. इसी तरह से जो सेकंड डिटर्मिनेंट है दिस वन, तो कोफैक्टर ऑफ द सेकंड एलिमेंट एंड द सेकंड एलिमेंट इज -1 एंड द कोफैक्टर ऑफ -1 विल बी नेगेटिव. जो सेकंड वाले केस में होता है वो हमने नेगेटिव ऑफ डिटर्मिनेंट लेना होता है. तो नेगेटिव ऑफ 63 माइनस 4 दैट इज 59. नेगेटिव ऑफ 59 आता है second cofactor. Similarly, we can find out cofactor of the last element. The last element is again 2, and what is its cofactor? That come out to be 12. So हम लोग cofactor इस तरह से find out करते हैं. cofactor हमारे help करते हैं adjoint find करने के लिए, adjoint of a matrix and then inverse of a matrix. ये आपने 10 plus 2 क्लास में भी पढ़ा होगा. So by this way we can find out the cofactors of a given matrix. cofactor आपका सभी एलिमेंट का फाइंड हो सकता है. ये सिर्फ फर्स्ट रो का फाइंड हुआ है. इसी तरह से सेकंड रो के भी एलिमेंट्स हैं तीन, और तीनों का all the three elements of second row, for all the three elements of second row, we can also find out the cofactor. Similarly, we can also find out the cofactors for the third elements of the third row. So by this way, we can find out the cofactors. Now, one more important thing which is there, that we have a term minor. This is important. The minor of an element of a determinant is the determinant obtained by omitting from delta the row and column containing that element. What does it mean? The cofactor of the element occurring in the mth row and nth column is, this time it's minor. So these are also said to be, which are the cofactors. These are also said to be the minors. So minor is a somewhat same name used for a cofactor. So if we say that in this particular question, the cofactors of 2, -1 and 2, we are able to find out. And these are also the minors of a first row, minors of first row, and the values come out to be -27, -59 and 12. So by this way you are able to find out उनके जो corresponding determinants आते हैं 2 by 2 matrices के, इसको हम minor बोलते हैं. This one, ये जो 2 by 2 के determinant है, this is named to be as a minor. So this is the minor of 2, this is minor of -1, and this is minor of +2 again. So by this way you will be able to find out the minor or the minors of a matrix. So let us see one more question we have. We have a determinant. The determinant is 1, 3, -2, 4, -5, 6, 3, 5, 2. So name it this determinant as a delta again. Now you just need to find out the minor of 1. So the minor of this matrix can also be written like this. This is M11, M12, M13, M21, M22, M23, M31, M32, M33. So you can find out a first minor M11. So this is the meaning of minor. 1 का जो determinant होएगा, you will expand by this 1. You will have this determinant -5, 6, 5 and 2. So this will be your -10 and -30, that is a -40. So your first minor comes out to be -40. Similarly, you will be able to find out a second minor M12. Now, uh, your second minor come out to be, by this element you need to expand, and you will have a negative value, and 4, 6, 3 and 2, 8 -18, and what it come out to be -10, and this come out to be +10, because there is +2 also. So this is the second minor we have, 10. Similarly, you can find out the third minor also, that is 4, -5, 3 and this. So that come out to be 35 also. So the by this way you will be able to find out all the minors of this matrix. So this is the way to find out the minors, minors and cofactors. So now you all know the properties of a determinant. Properties of a determinant. Now let us see the first property. The first property is, if each element of a row or a column of determinant is zero, means to say that चाहे वो किसी रो का चाहे वो किसी कॉलम का, अगर हर एक एलिमेंट जीरो आ जाए और बाकी का जो आपके पास एलिमेंट है वो हो सिमिलरली लाइक दिस इज C2 C3, सो इस कॉलम का हर एक एलिमेंट जीरो है तो इसका डिटर्मिनेंट जीरो होएगा. दिस इज योर फर्स्ट प्रॉपर्टी. And your second property is value of a determinant is not changed by changing the rows into columns and columns into rows. What I want to say, if we have a delta A1, A2, A3, B1, B2, B3, C1, C2, C3, अगर हमें किसी रो को कॉलम बना दें, मतलब रोज कॉलम बन जाए और कॉलम्स रोज बन जाए, तो वैल्यू ऑफ द डिटर्मिनेंट विल ऑलवेज बी सेम. एक्सपेंड करने पर वो वैल्यू कभी भी चेंज नहीं होएगा. दिस इज द सेकंड important property. The third property is if two adjacent rows or a columns of a determinant are interchanged, then the sign of the determinant is changed, but its numerical value will not change. What I want to say, this is your delta. You can expand delta and suppose its value come out to be x. Its value come out to be a number, a constant बोल दीजिए. Its value come out to be a, and suppose I expand a determinant. Then how to expand a determinant? By इंटरचेंजिंग रोज इनटू कॉलम्स. सपोज जो सेकंड रो है उसको हम फर्स्ट बना देते हैं और फर्स्ट रो को हम लोग सेकंड बना देते हैं, थर्ड को एज इट इज रख देते हैं, तो प्रोबेबली जो इसकी वैल्यू आएगी वो नेगेटिव ऑफ ए आएगा. सो व्हाट डज इट मीन, जो नया डिटरमिनेंट होएगा डेल्टा डैश, दैट विल बी इक्वल टू नेगेटिव ऑफ डेल्टा. It will always be there. This is also the important property. The fourth property is if two rows or two columns of a determinant are identical, then the value of determinant is zero. Suppose the first row is A1, A2, A3, and the second row is also A1, A2, A3, but third row is different, then its determinant will always be zero. And the same case may happen for column also. अगर दो कॉलम भी सेम है तो डिटर्मिनेंट का वैल्यू जीरो ही आएगा. You can check or you can verify. The fifth property is if every element of a row or a column is multiplied by the same constant k, then the value of the determinant is multiplied by the constant k. What is I want to say? Suppose हमारे पास मैट्रिक्स है A1, A2, A3, B1, B2, B3, बट जो थर्ड रो है उसमें हमारे पास है कांस्टेंट कॉमन KC1, KC2, KC3. तो जो डिटर्मिनेंट होएगा वो होएगा K टाइम डेल्टा. ये कांस्टेंट बाहर आएगा आपके पास. सो K टाइम डेल्टा डैश. डेल्टा डैश मीन K आप बाहर लिख सकते हैं और जो डिटर्मिनेंट आएगा वही डिटर्मिनेंट होएगा. तो स्केलर कैन कम आउट, तो वो स्केलर को हम लोग कॉमन निकाल करके बाहर कर सकते हैं. अब यहाँ पर डेल्टा किसका डिटर्मिनेंट है? डेल्टा डिटर्मिनेंट होएगा विदाउट के, लाइक दिस. तो इसको आप डेल्टा डैश दे दीजिए और यहाँ पर इसको आप रिमूव कर दीजिए डैश को. सो दिस विल वर्क. सो डेल्टा डिटर्मिनेंट है जो भी आपके पास है मैट्रिक्स A1, A2, A3, B1, B2, B3, C1, C2, C3. डेल्टा उसका डिटर्मिनेंट है और डेल्टा डैश डिटर्मिनेंट है in which we have third row multiplied with the scalar k. So this is another important property we have. One more important property, if each element in any row or column consists of two terms, then the determinant can be expressed as the sum of the two determinants of the same order. What I want to say, suppose हमारे पास डेल्टा एक डिटर्मिनेंट है, इसमें एलिमेंट a1 प्लस अल्फा वन, a2 प्लस अल्फा टू, a3 प्लस अल्फा थ्री, b1 b2 b3, c1 c2 c3. So it can be written like this: A1, A2, A3, B1, B2, B3, C1, C2, C3, and plus alpha 1, alpha 2, alpha 3, B1, B2, B3, C1, C2, C3. So that will be the sum of the determinants. The determinant is delta 1 and its determinant is delta 2. तो इसका मतलब है ये टर्म्स को हम सेपरेट सेपरेट करके सेकंड डिटर्मिनेंट बना करके ओवरऑल डिटर्मिनेंट निकाल सकते हैं. So this is another important property. One more important property is this: prove that the value of determinant of a diagonal matrix is equal to the product of the diagonal elements. Suppose we have a matrix in which we have A1 0 0 0, B2 0 0 0, C3. डायगोनल मैट्रिक्स का जो डिटर्मिनेंट है, डायगोनल मैट्रिक्स वो मैट्रिक्स होता है जिसका सिर्फ डायगोनल एलिमेंट ही नॉन जीरो होता है और बाकी सारे के सारे एलिमेंट जीरो होते हैं. तो इसका डिटर्मिनेंट होएगा A1 B2 C3. You can easily check that. This is they are saying. And another important property is prove that the value of the determinant of a skew symmetric matrix of odd order is always zero. Value of a skew symmetric matrix, value of the determinant of a skew symmetric matrix of odd order is always zero. स्क्यू सिमेट्रिक मैट्रिक्स ऑड ऑर्डर का उसका जो डिटर्मिनेंट होता है वो ऑलवेज जीरो होता है. तो हम लोग मान लेते हैं कि ए कोई स्क्यू सिमेट्रिक मैट्रिक्स है. स्क्यू सिमेट्रिक मतलब ए ट्रांसपोज इज नेगेटिव ए, देयरफॉर यू कैन टेक इट्स डिटर्मिनेंट. सो डिटर्मिनेंट विल बी इक्वल टू, हम लोग ये भी करते हैं कि इसका जो ए मैट्रिक्स है उसका ऑर्डर मान लेते हैं एन. तो -1 raised to power n, a determinant will be there. And what will be that? Uh, because n is odd. तो अगर हमने n odd लेना है तो -1 raised to power odd of a determinant, that will always be negative of a determinant. And a transpose is there, and a transpose डिटर्मिनेंट हम लोग ऐसे कर सकते हैं. और यहां से देखिए ए ट्रांसपोज, यहां से ए ट्रांसपोज का जो डिटर्मिनेंट होएगा वो ए डिटर्मिनेंट के ही बराबर होएगा. और ये नेगेटिव ए इस तरफ आकर के प्लस ए हो जाएगा और जीरो मैट्रिक्स. तो 2a determinant is zero matrix, and similarly a determinant will be a zero matrix or a null matrix. So this is another important property we have. The next property: determinant of a symmetric matrix of even order is always a perfect square. You remember this: determinant of a symmetric matrix of even order is always a perfect square. You know what is the meaning of a perfect square? Okay, students, it is clear to you?
Yes, sir.
तो
यस
ये
सर।
प्रॉपर्टीज हैं जो हमने 10+2 क्लास में भी इसके बारे में थोड़ा पढ़ा होगा, और हम लोग इनको यूज करके डिटर्मिनेंट्स एक्सपेंड कर सकते हैं। डिटर्मिनेंट एक्सपेंड करना आपको जरूर आना चाहिए। You can solve the determinant by using any of the properties or by expansion method. So you must go, or you must be able to expand a determinant. And one more thing which I want to clear, that is a Cramer rule. Cramer rule for solving the equations. But you will use the method only if it is asked. अगर क्वेश्चन में पूछा गया है कि आप क्रैमर रूल से करें तो तभी करेंगे, अदरवाइज आप लोग आगे जाकर के गॉस एलिमिनेशन और गॉस जॉर्डन वगैरह करना है, उससे भी आप सॉल्व करेंगे, उससे ही करेंगे। इवन सपोज हमारे पास है 2x1 plus 3x2 is equal to 5, 11x1 minus 5x2 is equal to 6. So this is a system of equation. Two equations are there and two unknowns are there, x1 and x2. And you need to find out your delta hai, that will be 2, 3, 11 minus 5, and it come out to be minus 43. And your delta 1 matlab first column will change, second column will be same, but in place of first column you will have these constants 5 and 6. So what it come out to be minus 43. Similarly, you will have a delta 2. Now, first column will be as it is 211. The second column will change 5, 6. And this will also come out to be negative 43. So the Cramer rule says that for finding the first unknown, we should have delta 1 over delta, and for finding the second unknown, we should have delta 2 over delta. Because all the three values are same, so you will have 1 value of these unknowns. So clearly, 1 should satisfy this system. If we put x1 is equal to 1, x2 is equal to 1, 2 into 1, 2, 3 into 1, 3, 2 plus 3 is 5, 11 into 1, 11, 5 into 1, 5, 11 minus 5 is 6. So system is satisfied. The same method may be applied for three equations also. So you must have practice about that method. Now you know that way how to find out the inverse of a matrix by taking the adjoint, and you can compute the inverse. So we should have a matrix A with a row. First, first row is 104 minus 2 to 5, and 3 minus 1 2. So this is a matrix A. Now you will be able to find out A determinant, and you have to expand it 1 into 2 into 2 is 4 plus 5 minus 0 minus 4 minus 15 plus 4 2 minus 6. So 9 and minus 16. Uh, Sorry, this come out to be plus 16. Uh, there is a negative 4, sorry. So this should be negative sign. Please rectify this. So what it come out to be? This come out to be negative, and this is 2 minus 6 is there. So this come out to be plus, this come out to be 25. So A determinant is 25, which is a non-zero value. If the A determinant is a non-zero value, this means A inverse exists. This is the method actually, that whenever A determinant come out to be non-zero, and what does it mean? It means A is a non-singular matrix. Remember. So if A is a non-singular matrix, it means inverse of this matrix always exists. Now you just need to find out the cofactors of all the rows. Therefore, cofactors of the first row of a determinant R, the cofactors will be. Now you just see how to write down cofactors by first row. ये हमने पहले भी कर लिया cofactor कैसे find करते हैं 2 5 by finding out the minors. This is your first minor. The second minor will be -2 5 3 and this is -1. The last minor 2 2 negative 3 -1 is there. Now you can find out the minor cofactors of the first row. This come out to be 9 and this come out to be 19. 19 मतलब T2 is there, -15 is there, and sorry. The cofactors of first -2, 3. This should be 2. So this come out to be 19 and this come out to be -4. So these are the cofactors of a first row. Similarly, you will be able to find out the cofactors of a second row 4, 14 and 1. And the cofactors of last row will be 8, 3 and 2. Now you can find out adjoint of a matrix. Adjoint mean first cofactor will be written first. So adjoint will be 9, 19, -4, 4, 14, 1, 8, 3, 2. This will be the adjoint by taking its transpose. So 9, 19, -4, 4, 14, 1, 8, 3, 2. So this is your adjoint of the given matrix. And your A inverse will be adjoint of A divided by its determinant. So 1 over 25 and this matrix 9, 4, 8, 19, 14, 3, -4, 1, 2. This is your inverse of the given matrix. So by this way, you will be able to find out the inverse of the matrix. Now, earlier we have done the Cramer rule. Now we have the matrix method for solving a system of equation. This is another method which we must know. And the system is 2x plus 3y is equal to 5, 4x plus y is equal to 5. Now they have said by solve this system by matrix method, and you have to use the matrix method only. The system can be written like this. This you have already done in 10 plus 2 class. Now this system can be written like this. Ax is equal to b. This is b matrix, this is x matrix, and this is a matrix. Now, what do you know? You have to use this method x inverse from this x, sorry, x can be written as a can be taken to the other side. So it will be a inverse into b. This is we require. So you just require the A inverse matrix here into the B matrix. B matrix is clear, 5, 5. Now you just need to find out the inverse of this matrix. And then you can substitute the value here and get the required values of the variable. Because your X matrix is a column matrix XY. So let us put the inverse. I am straight away putting the value that is -1 by 10, 1, -3, and this is a -4 and 2. So you just need to compute. This is X, Y matrix. This come out to be, you have to solve this. This come out to be -10 and minus 10. So it can be taken inside and it will give you 1 1. So therefore your first value x come out to be 1 and y come out to be 1 also. And clearly your value of x and y is also satisfying this system. So this is another method for solving the system of equation. The same method may also be repeated for finding out the solution of the system for three equations. So I stop my class here. Thank you very much. You can ask me about your queries.
Shut out, sir.